11.1. Okay, let me find the current going through each one of them. So I'm switching everything to phasor. This is 200, this is j omega L. 2000 times 0.2, that's 400 J. Now I can do current division to get I sub R and I sub L. And if I know either one of them, I can find the voltage across. I'm ready to go. I sub R equals the source current, which is 12 angle 0, times the 400 J over the sum of them, 2 plus 400 J. Times 0 comma 400 divided by 200 comma 400, and according to my calculator that's 10.73 angle what, 26.6 roughly. See if you get that. What's I sub L? 12 angle 0 times the 200 over 200 plus 400 J. Current division again. And I came up with 5.4 or 5.37 angle negative 63.4. Let me know if you get these numbers.
Yeah. I'm not. Dang it.
Now, if I know actually either current, I can find the voltage across. Let's call this V. Then parallel. So I can find V, which is 200 times I sub R. (200 times I sub R). 200 I sub R is 10.73 angle 26.6. So that voltage is what? 200 times 10.73, 2146 angle 26.6 degree volts. This is amps. So what's the current as a function of time? I sub R as a function of time from this equation, 10.73 cosine, was it 2000 T plus 26.6. What's the current I sub L as a function of time? I sub L is 5.37 cosine 2000 T minus 63.4. What's the voltage as a function of time? 2146 cosine 2000 T plus 26.6 volts. These as a function of time. And we know what I sub source. I sub source as a function of time, that was given to us to be what? 12 cosine 2000 T. So we know all of them. Now we can find the power absorbed or supplied by each one. Let's take the source. The source is going to be supplying the power. The power supplied by the source, instantaneous power. It's voltage times the current. The voltage is what? For the source, 2146. This will be supplied, so that's a minus. That means supplying. 2146 cosine 2000 t plus 26.6 times the current, which is what? 12 cosine 2000 t. Now they want it at a certain time, 1 millisecond. Negative 2146 cosine 1 milli, that'll be 2 here. 28.6 is it? This number, when you put 1 milli, times 12 cosine 2.
Yeah, the book has like the total radius.
Oh, I know. You know what? I bet you this is in radian. That's in degree and this is in radian. This is 2 radian, 26 degrees.
So we need to put.
Let's see, 26.6. How do you convert that? 26.6
Why would they change it to radian all of a sudden?
times. Usually we're dealing with cosine function. We always try to write them in radian, you know, sine trig functions. What's 2 pi f? That's what W. F times t. Think about it, right? Look at that number. That's what W is, 2 pi f, right? Times t. What's t?
1 million.
T, which is 1 over f. What happens with these?
I can't actually.
We can't see it.
Oh. W, that's this number W. W is 2 pi f. F is the frequency. T is the time, which is 1 over the frequency. So if you do the math, what's W times T? 2 pi. This is F times 1 over F. What happens to the F's?
They cancel out.
Cancel. What do you end up with? 2 pi. You know, so what's the units for 2 pi here? Radian.
But then why is it 2?
So this is radian, and that's degrees. So we got to make sure when we switch them, this is 2 radian actually, and that's 26 degrees. This is 2 radian plus 26.6 degrees, and this is 2 radians. So we got to switch one to the other. 26.6 degree. Let's switch it to radian. 26.6 times pi. Pi roughly 3.14 divided by 180. Plus the 2. 2.46. Times 12 cosine 2. Let's switch the calculator to radian mode. Where's mode on this one? Mode. There we go. Let's go to radian. So this will be negative 2146 times the cosine of 2.46 times the 12 times the cosine of 2. is at a negative 8322, which is 8.3 kilowatts supplied. Do we have that answer? Negative 8.35 kilowatts. Let's try another one. Let's try the resistor. Power, instantaneous power by the resistor. The voltage across the resistor times the current. The voltage across the resistor.
Should there be PR? Because you're getting the power across the resistor.
Oh yeah. Resistor. And that will be the voltage across the resistor, which is 12 cosine 2000t times the current through the resistor, which is 10.73 cosine 2000t plus 26.6. Is that the same number I did before? Did I use? Where was the first one? Is that the same number? No, the different numbers. I thought something. 12 cosine. Yeah, okay. That'll be 12 cosine, and this is 2 radian, times 10.73 cosine. What's that? 2 radian, and we figured that number 2.46. Oh no, wait, the voltage. The voltage is not 12. What was the voltage cross? 2146. I looked at the wrong table. 2146 cosine, where's the voltage? Plus 26 degrees. So that's 2146. This is 2 radian, that's 0.46, 2.46 radian. Times 10, and the current through the resistor is correct, 2.46. I just gotta look at the wrong row, or the right row. 2146 times cosine. Cosine what? 2.46 times 10.73 times cosine 2.46. I got 13886, which is 13.9 or 88. 13. I got 89 kilowatts. They have 98 instead of 89. Could be rounding errors quickly. This is actually absorbed. The resistor will absorb the power. Notice what I'm supplying. The source supplying that much. This absorbing that much. That tells me the inductor in this case is going to do what? It's not going to absorb. It's going to supply the power. It has to. Power supplied has to equal the power absorbed. This one took 13.8 or 13.9 kilowatts. This one only gave you 8.3 kilowatts. Where is the other one coming from? It has to be coming from the inductor. So let's look at the inductor. It should be a minus, which means supplying. Let me look at the right equation just to make sure I don't screw things up. It's the voltage across the inductor, 2146 cosine 2000t plus 26.6 times the current through the inductor. And put my finger on the right one. 5.37 cosine 2000t minus 63.4. And it has to be supplying, so it's a minus.
So does it mean you always do the inductors and stuff last?
No.
Because like say we didn't know it was supplying,
Yep.
we figured it out, we would get a positive number.
Yep, then you'll know when your power supply equals power absorbed, something is not right.
No.
Right? You go back, oh, wait a minute, that must be then doing that. So this will be negative 2146. We know that number is what, 2.46 radian times 5.37 cosine. We know that's a 2. 2 take away from it. What are we subtracting from it? Let's.
0.89.
What is it?
Comes out to 0.89.
The final answer?
Yeah.
0.89 radian. That's the 2 minus, you change that to radian, which is 63.4 times 3.14. You divide it by 180 to convert it to radian. And it's 1.1. So 2 minus 1.1 is roughly that number here. So now let's see what that number is. 2146 cosine 2.46 times 5.37 times the cosine of 0.89. I got negative 5. If you don't put the minus sign there, if you just carry the math with the right angles, the equation tells you minus plus automatically.
How'd you get that?
If you just plug in these numbers, just the way these angles, try that. See what the calculator is giving you. It should give you a minus, which means supplying. Try that.
Oh, yeah.
Does it give you minus? So you don't have to think about it. If you just plug in the equation the correct way without you putting the minus sign in the front, let the math tell you that. Like if I don't put the minus sign here, the math will tell me that is a minus number. I don't have to say, I know it's supplying, the source is going to supply. So if I don't put it there, I just plug in these numbers in. If you put them in, guaranteed the answer is negative. And if you put these numbers in, guaranteed the answer is positive. So I don't have to, which one is supplying, which one is absorbing. It's going to tell you, we know the source in this case is going to supply the power. There's the only source you have there. So you don't have a lot of options there. But that's probably why you begin the wrong numbers, because one part of that is in radian, the other part in degrees. So when you're doing the math, you're going to convert both values now. When you get the numbers, convert them both to actually radian or both to degrees, either way. Well, no, if you just look at the unit, that's why we do this just to convert back to the time, but when you really look at the units, that's what, once you see pi, you know you're in radian. They could have put that angle in radian, but the problem with the radian, you and I, we have no concept of radian. When someone said it's 1.7 radian, you go, what is that? But if I said to you 90 degrees, you know exactly where that is. If I say 130, you know which quadrant. If I said to you 1.47 radian, you know which quadrant even? So that's why we tend to put the values in degrees. It makes it easy on our brain to see where they are. I can visualize where that vector, which quadrant. Where radian, we struggle with it. Any other ones?
Oh, it's still recording.
Yeah, it's okay. Any other ones?